Hello everybody, I'm Tiziano and this is the second lesson on photogrammetry we have today. It's about Zephyr, which is a software to do photogrammetry. It's just for Windows, so we have two different tutorials, one of Visual SFM for Mac user and Linux user, and this tutorial on Zephyr just for Windows user. I've chosen to do two different tutorials because Zephyr is actually a much more complete software for photogrammetry compared to the other one I've found for Mac. And these kind of software are changing a lot nowadays, so I will expect to find a lot more software in the next few years. I didn't find a good one because I was looking just for free software on the web, and Zephyr, it's a very good, the free version of Zephyr, it's a very good software and it's worth trying it. And so if you have access to a Windows machine, I would suggest to do this part of our course on Windows if you are able to. Okay, so the interface is pretty basic. Once you open the software, you can just drag your dataset on top of the interface, and a wizard of project creation will appear with just few click to set up everything before starting. The first option that it's already checked, it's a check online for pre-compute camera calibration. That means that our photos need to have inside the properties, if you go to details, you can see actually with which photo camera was the photo was taken, what was the ISO setting, focal length, whatever. And this is used to look for distortion data on the web. This happens and also with the other software we have talked about. And that part is really needed because to get a proper scan with photogrammetry, you need to correct all the data present in the image for distortion, so that the data in the photo is actually metrically correct. So it's similar to a photo taken with a pinhole photograph, which is older way to make photographic machines, and it's more close to a geometric projection of point compared to a system based on lens. So the camera distortion, it's intended to get the photo right at the beginning. So you can have some problem if you use a really old photographic machine or a really new one. So if in the next step you go to the next step, now the software is looking for data on the web, and it found some matrix to correct this data. If this doesn't happen, it's better if you take the photos with a different device. So first thing I suggest is just make a few photos and test if they work with your with the software you're using. Okay, I go back. Now here we can decide to let the software do all the steps to get the model in just one click. So we can also compute 3D model after project creation and compute texture after surface extraction. I will leave this unmarked because we will modify the 3D model before getting the texture. The mask image, it's very useful when you have a dataset where the main subject moved a little compared to the background. Because photogrammetry take in consideration not just the subject in the photo, but also the background. If the background has a lot of details like this texture here, this can be used for aligning the photo as well as the part in the center. So if I'm not sure about the subject to be completely still compared to the background, it's better if we mask away that part in the photo. This is really easy on Zephyr 3D. If we go next with these settings, next again, here we have the mask part, and the status says that didn't found the mask because we did it already. So we can launch this part of the software, which is a different piece of software, running some very easy algorithm of masking, and it works pretty easily in this way. We just draw some lines on the subject. The red lines are the subject and the blue lines for the background. Then we can calculate the mask with this button. It's really similar to the selection brush in Photoshop. And we can correct it if it doesn't get it well. So we can correct this part, add another brush stroke here, and another blue one here to make better delimitation. We run again the quick tool to mask, and again I correct a little more here and here. Here was a problem because we had a very white part similar to the other places. It's not needed to get a perfect mask, it's just to avoid the place that can have some level of detail. This part actually doesn't contain any detail, so I could have left it without any masking. But this way we get a better finish. So then when we are satisfied, we save and go to next photos. As you can see, this can be pretty time consuming. This is a pretty fast solution for masking, but imagine if you have, let's say, 50 photos, which is the maximum we can put in the free version. It will take around 1 minute for photos. It will take more than an hour to do all the masking. So if you plan to have a very big data set, it's better to find a way to let the subject be very still with the background, or having no background at all. So if you manage to get in a place like a very white room, will be better for sure. So when I'm done with masking, I just close the masquerade, and now I can refresh and we will see that we have 2 masks on this photo. I can also choose to mask just some photos that I know that can have some problem and leave the other one as they are. Okay, but for this data set we don't need that, so I just uncheck mask image and go to next with the check online for pre-computed camera calibration and compute 3D model after project creation. Okay, those are our photos, those calibration setup. Here I just choose the different preset for the camera alignment. This is camera alignment preset. We have different setup. I can choose between close range, because this is a close range subject. Urban is not the case, aerial photograph it's not the case. We have human body, which is right for our purpose. And then I have selection of the quality of our alignment. So for our purpose, fast can be fine. But since the dataset it's not so huge, we can also use a better quality, medium quality, like default, because the camera alignment it's the most important step in our process, and we want it to get it right. If you see that takes a lot of time, you have a lot of photos, you can just switch back to fast without any problem. Okay, we click to next. And then this is the dense point cloud creation preset. We still leave human body as a category preset, and has a quality. This time I will choose fast, because for 2 reasons. Mainly, we don't need this model to be really high quality in terms of number of polygons. So if we start with a very dense point cloud, we will get a very dense 3D model at the end, but this is actually not needed for our purpose. So we will start with fast, then see the results, see how long does it takes, because if you start with a very high quality picture and a very big data set can take a lot of time, like around hours, but really depends on the computer you're using and the dataset you're using. So we don't know at the beginning, it's better to start with a fast preset. We can always correct this preset later, because we can always start again from sparse point cloud, or reconstruct another dense point cloud, and reconstruct another mesh later without any problem. So we switch to next. And surface reconstruction, it's the step just after the dense point cloud. So the first alignment will bring the camera together, then we will get a sparse point cloud while the camera will be aligned. Then we generate the dense point cloud, and then from the dense point cloud meshes. So this preset is for going from dense point cloud to mesh. Also here, human body and the fast preset. Okay, next. Now we are about to start with hitting run. I prefer to move a little this window so later we can see if something is happening on the interface. And before starting the project wizard, I've switched to log, where we can see actually what's happening. But you cannot switch it now, so you have to start again the preset. Okay, now I hit run, and I've also checked the log to have the log actually being produced, and system info to monitor our computer during the process. If you want, on Windows, you can also hit Ctrl-Shift-S to go to the task manager and see how your computer is behaving during the reconstruction. We can see that we are using a lot of CPU, some memory, not full of it. I have quite a lot of memory, I'm using half of it. And we are actually not using that much the graphic card. I have an integrated one, which right now I'm probably using that for recording the video. And I'm using just a little bit of my graphic card. And this depends a lot on the software. And usually the expensive software are more able to use properly your graphic card. And I think that the paid version of Zephyr uses a bit more the graphic card instead of the CPU. Okay, right now we can see the software. It's looking for markers on our photo, and it's starting to match two photos together. So it's looking for pairs of photos that can be positioned together. Now it's reconstructing the point cloud, so it's pretty fast. I don't even need to speed up this video probably. We have seen appearing something on the interface that was the first camera alignment and the sparse point cloud. Right now the software is computing Delaunay triangulation. It's probably the meshing part. Okay, so right now we just have to wait a moment. Okay, done. Pretty fast. Okay, this says that the software managed to use all of our photos. This actually doesn't happen all the time. So that means this was a good data set with all the photos on the same, that has a good overlap one to the other. They're all in good focus, so the software managed to put them together. Okay, with finish. Now this is our 3D model. Now we are going to do a quick setup on this mesh. So if you want to work on the mesh, you just click this part, select it, and now you are working on this file. If I deselect this, go to dense point cloud, click on the dense point cloud and select it. Now I'm working on the point cloud, so you can see how different the different part of the files are constructed. So the first things that our software got was the sparse point cloud, where you can see the camera alignment. So if everything went well, all the camera will be in the same position as you have shooted them, and you will see this very rough point cloud, which actually are the key points extracted from the photo for making the first alignment. Then after this, the software creates the dense point cloud, which is looking for very tiny details in between the marker that I've found previously, and try to guess the position of each point. Okay, and then we switch back to meshes. We still didn't have a texture mesh because we didn't did it yet on the when we started the preset at the beginning. We didn't check for getting the texture mesh, so we don't have it now because I want before to clean the part that we don't need on this model, so we can create the mesh, the texture just for the part we need. So this area mainly. Okay, so I'm starting to select. If you go at the beginning, you are on animator, we can switch to editing. And here you find the selection tool that you can use to select points, and the edit tool, so you can delete, cut, copy, invert selection, do some filter on selected part. So here you can choose decimate, densificate, retopology, filter, or smooth just some part of our mesh. But we don't need it for our purpose right now because we will make this modify on directly on Meshmixer when we start to model our parts. Okay, we close this part, and right now we choose to select by hand because it's pretty easy part. Before selecting by hand, I'll show you another tool, which is if you have a very complex selection to be done and it's all maybe white, we can also pick a color from our scan and choose a threshold of pixel to be close to that color, and see we have selected all this part. Be careful that this selection didn't pick also some parts from the eyes because they're white too, and we are satisfied with this color selection. We can go here and delete this part. The other part I will probably do by hand because this color is much more similar to my eyes color, so I can just use lasso, which is probably the easiest way to get a selection, and remove, delete. And if you need to turn your view, you need to hit pause, turn your model, find a nice position where you can edit some other part, resume, and then select. You can also hit delete on your keyboard. Select, delete, pause, we turn again the model, resume, select, and delete again. Okay, we are done with the cleaning of the mesh. Right now we need to check some other stuff. I just unlight. Okay. I just deselect this so I can have a clearer view without the cameras on my screen. Okay. Okay, done. So this is our model, and I've drawn some marker on my face for a specific reason, not just to be more fancy in the photos, but because I need to scale my face, and actually it's not so easy to measure something on some body parts. So my technique for this kind of a scan is to draw some marker that are useful for the alignment of the photos. So the software can use this marker to get a proper alignment. But also they're useful for me to take measures. So I've taken note that from this point and this point I've measured actually on my face. And from this point to this point there is 104 millimeters, and from this point to this point there is 88 millimeters. So we have a reference for scaling. Here on Zephyr, somewhere here, quick measurement, we have a tool. We begin to measure from this point to this point. Okay, when you have drawn the first line, just check it's from different angles that runs exactly from this point to this, because maybe we have selected a point that it's on the background, so maybe it's not correct. Here we can see we have a number which is actually a kind of random number, because sometime I got 0.3, sometime 4, sometime 10, whatever. And this is a random scale because the software actually doesn't know the scale of our model, because we don't know how the subject was close to the sensor of the camera. We can start from this number to guess distance, scale factor, sorry. So we can say, I wanted to get, I don't want to scale this model too much, so I'm looking for the closest number to this that it's near to my 104 millimeters. So this is a 4 millimeter. We can say that it's a 4 centimeter because this doesn't have a unit actually, because I don't want to increase the resolution too much, because this software it's using 4 decimal. So 4 decimal on millimeters will be probably too much for this software. So if this is 4, we can say that it's 4 centimeter and scale of just from 4 centimeter to 10 centimeter. So I can say that this is 10. I want to get 4.8 centimeter to be 10.4 millimeter. So I just say 10.4 divided by this number. Okay, divided by this. And it says I need to scale it up of 2 times .1276 so on. So I can just select this scale factor, 4 decimal are enough, and close the measure tool, go to scale, rotate, transform, translate object, all structural object. It's applied to all my data, so cameras, first point cloud, and point cloud. I will scale everything. Okay, so I just select this, say that the scale is 2 point blah blah, and okay. So we scaled up the model. We just need to transform this so it's more well oriented to our coordinate system. So we can rotate it I want it to be aligned a bit more with my coordinate system. Don't do this with too much precision, because actually the part that is important on our software, it's not the position on the space here, but it's the position relative to this bounding box. So this bounding box will decide where is the origin of our model. So we have a smart reset here that will put the box aligned with the main coordinate system of the file. And we just drag this face and rotate it to be perfectly aligned with the face. Okay, so I'm looking to move it inside unless I touch my hair, because probably this will be a bit good guess of the middle point of my face. Move this a little up until I touch the neck. This box is not cutting in any way the model, it's just for placing the coordinate system in the middle. Okay, we can close this, and it's not more visible because I've unchecked this. If I check it and close it, I will still see my box. If I don't check it and close, I won't see, but the box will be still there. Remember that the box is actually the coordinate system. Last part of the tutorial, we will check again the scale. So I go back to quick measure, begin, click on this point, click on this point. I will see we are at 10.309, so it's pretty close to the 104 millimeter I was talking about before. Is just 1 millimeter less, so I think it's fine. It's probably depending on where I click exactly on the mesh. We can check also the other reference I've taken. So I'm sorry, start again. So click on the start. You cannot use anymore the left mouse button, so you have to move pressing the wheel of the mouse. Okay, and we see that it's 9 centimeter, so it's 2 millimeters away from the 88 millimeters I've measured on my face. So this means that our scan is not deformed. So it doesn't happen all the time, so it's better to have a second measure for check later. The other reason I make two measure, because I wasn't sure to have a good quality of the texture here. So if those 2 points weren't good to make the measurement, I could still use another one. Okay, so we can close this. We are almost done. The latest part, if you look to this model, actually we have not a real texture. This is just a color of the single vertex. So we have the same resolution in the vertex and in the texture. But this software, it's made pretty well to have also a texturing process. So we can click, select our mesh, go to texture mesh generation. If we have made more than one model, we can select it here. Be careful to work on the right mesh. And we can select the best photos we have to get a nicer texture. And if you select less photos, will take also less time to do that. So I just choose the photos that cover all my face, but at the same time has the same color range. So this photo is a bit darker than this, so I can choose this because it's more close to the style of the other photos. Also, this is not so good, so I can choose maybe this from the front side, maybe this from the side, because this has a bit more of a highlight, I don't want it. and maybe this is good for the other side, and this can be a good one for the bottom side. Okay, so we have just 5 cameras selected. Texture in preset, general, we can choose anything else. We choose default single texture. It's enough to get a nice detail. Next, again run, and we wait for the process to finish. This will take some time depending on the quality of the photo, mainly I think, and the number of photos. Okay, the process is finished right now. As you can see, the model seems to have a higher resolution, but actually this resolution is not on the mesh, but it's on the texture. Okay, this is our textured mesh. Will take a bit of time to render because it's a bit heavier. As you can see, if you zoom in, seems to be a lot of detail which actually are not on the polygon of the mesh. So I'm clicking on this button to highlight or not the texture. And we have some problem in the mixing of color between the two meshes. So here it chose a mesh with a photo with a slightly different color, and here another photo with a darker color. So this is another good reason to get a proper shot with a nice exposure on all the photos. So you can correct the photo later, or you can shoot in manual mode. But if you shoot on manual mode, you will need to have a very proper illumination. So I had a room with a darker light on the side and more light from this side. So we could not avoid this problem. Okay, so we are done. We can just save our Zephyr project. So it's, we can say, Tiziano Berti. Sure. And we want also to export our model. There is a specific button here to export textured mesh. And we can upload it to Sketchfab. We will see this during the lesson, if you don't know that. And we can select also OBJ with separate material, which is this format. The texture type can be just JPEG in this time, and we can choose to export into a single texture. The texture will be scaled to the nearest power 2, or we can choose a different setting. And that's it. We can export. I can call it again Tiziano Berti. Save. Will take a bit of time also, this part. Okay, here is the file, and I don't know exactly where I put this. I can go back here. Okay. So we just open this with some other software to see the result if it's correct. So dataset, and another interesting thing to see, this is our file, OBJ. We have also MTL extension, which is the material, and we have also a very funny texture, if I'm able to open it. Okay, this one. Okay, so this is how the photogrammetry texture comes out. These are not actually real photos, they are kind of deformed to follow better the mesh. We have a very nice eyes here. Okay, cool, we are done. Thank you for following our course, and see you in the next tutorial.